Hello guys, welcome to I Plus Education. This is Sayyid Ismail. Today I am going to discuss one of the special functions, that is beta function. Here we will see the mathematical definition of beta function. Beta function, the integral 0 to 1 x power of m minus 1 into 1 minus x power n minus 1 dx, where m comma n is greater than 0, is called beta function of m comma n. It is denoted by beta of m comma n is equals to 0 to 1 x power of m minus 1 into 1 minus x power n minus 1 dx. Here m is there, so write down m minus 1. N is there, write down n minus 1. Here x is a dummy variable. Here we have x dx. This beta m comma n can also be expressed in some other variable as integration 0 to 1. Instead of x, we can take another variable y power of m minus 1 into 1 minus y whole power of n minus 1 dy, y dy, or we can express by some other variable as t, 0 to 1 t power of m minus 1 into 1 minus t power of n minus 1 dt. These are the various ways of expressing beta m comma n. One of the important property of this beta function is beta of m comma n is equals to beta of n comma m. Now let us see the proof of this property. We have seen that beta of m comma n is equals to integral 0 to 1 x power of m minus 1 into 1 minus x power of n minus 1 dx. Now this beta function is completely based on substitution. So this unit is mostly based on substitution. So here we will take this 1 minus x and substitute this as some other variable t. So we are substituting this variable t as 1 minus x. Now here we have dx. Differentiate with respect to t. Derivative 1 is 0. Derivative of x is minus dx. So we have minus dx is equals to dt. Dx value is minus dt. Here we have limits 0 to 1 for x. Now we want new limits for t. New limits when x equal to 0, that is lower limit. Substitute 0 here. We have 1 minus 0 is 1. So t will become 1. Upper limit when x is equals to 1. Here we have upper limit for x is 1. Substitute 1 here. We have 1 minus 1 0. So t will become 0. Now this beta m comma n is equals to integral for this new variable t equal to 1 to 0. Here I have x. So from this get the value of x. We have x is equals to 1 minus t. So 1 minus t power of m minus 1. Next we have 1 minus x. 1 minus x value is t. T power of n minus 1 into dx. Dx value is minus dt. We know that negative of integration a to b f of x dx value is, this negative sign will interchange these two limits. So it will become b to a f of x dx. Similarly, this negative sign will interchange these two limits. So it will become 0 to 1, 1 minus t power of m minus 1 into t power of n minus 1 dt. Now this can also be written as 0 to 1. Write down this first. t power of n minus 1 into 1 minus t power of m minus 1 dt. Now compare these two integrals. Here we have m minus 1, n minus 1. Here we have n minus 1, m minus 1 for variable x, for variable t. So this will become beta of n comma m. So this is the proof of this property. This property is very helpful in solving so many problems. Beta of m comma n is equals to beta of n comma m. It means that m or n can be interchanged. Till now we have seen the definition of beta function. Beta m comma n is equals to integration 0 to 1 for some dummy variable x. We have here m minus 1. So the power of x is m minus 1 into we have 1 minus x dx whole power of n minus 1. So here we have n minus 1. We have seen this definition. Next, what we have seen, beta of m comma n can also be written as beta of n comma m. In the next class, we will see this beta function. Beta of m comma n can also be written as integration 0 to infinite. Here we have x into 1 minus x. Here we have product of these two functions. Now this can also be written as x upon 1 plus x dx. Here we have to take the sum of these two values as the power of m plus n. Here we have m, so we can write down m minus 1 here. Similarly, this can also be written as integration 0 to infinite. We have to take x divided by 1 plus x dx. By this property beta of m comma n, we can replace m with n. So we have n minus 1 here. In place of m, write down n plus m. That is m plus n only. So we have beta m comma n, this relation. Next we will prove this in the next video. 0 to infinite x power of m minus 1 divided by 1 plus x whole power of m plus 1 dx. 0 to infinite x power of n minus 1 1 by x power of n plus 1 dx. Similarly, we have one more definition of beta, that is property of this beta function in terms of x. Here we have to take 0 to 1 as the limit of integration. The denominator will be same, 1 plus x. Here I have to take x plus x dx. Now the power of this denominator will be the sum of these two values, m plus n. Here we have m, so write down m minus 1. We have n, so write down n minus 1. So these three relation we will prove in the next class. One more value of beta m comma n in terms of trigonometric ratios we will see, that is 0 to pi. Here we have x. In place of x we will take sine theta. In place of 1 minus x we have cos theta d theta. Here we have m minus 1, m minus 1, n minus 1. Now here we will have twice and this will become pi by 2. Here it will become 2m and 2n. So beta of m comma n, apart from this x, we can also express in terms of 0 to pi by 2 sine power 2m minus 1 theta into cos 2n minus 1 theta d theta into 2. So these are the various ways of expressing beta m comma n. Also, we have seen the definition of gamma function. We know that gamma of n values integration 0 to infinite. We have e power of minus x into x power of n is there. So n minus 1 dx. We know this gamma function definition. You can see the videos of gamma function on I Plus Academy. Now we will derive the relation between this gamma function and beta function, that is beta of m comma n can be expressed in terms of gamma function, that is gamma of this m into gamma of n divided by gamma of sum of these two, m plus n. This is one of the important relation between beta and gamma function. Using this relation we can solve so many questions based on beta and gamma function.